Welcome back, Focus Learners. I am absolutely thrilled you're joining us today. We're going to take a massive deep dive into an incredible open source ecosystem, literally exploring its central nervous system, its GitHub organization page. Today's explainer is all about PlayCanvas. You know, if you've ever wondered how high-performance interactive graphics actually make their way onto the web without needing massive downloads or some clunky plugin, well, you're in the exact right place. We're going to unpack exactly what PlayCanvas is, why it's turning so many heads in the developer community, and the highlight features that make their tech stack so incredibly robust.
Okay, let's dive into this, because this question really gets to the absolute heart of the challenge. Historically, if you wanted high-fidelity 3D graphics, immersive environments, or complex interactive physics, you were building a native application. The web was, largely flat. But the open source tools we're looking at today are completely changing that paradigm. They're allowing developers to push desktop-class graphical experiences directly through a standard web browser. It's a total game changer.
So here's our roadmap for this explainer. First, what exactly is PlayCanvas? Second, why does it matter? Next, we'll break down their two main highlight features, the engine and the editor. Then we'll get into their cutting-edge Gaussian splat tools. And finally, zoom out to the broader developer ecosystem. Let's get to it. Section 1. What is PlayCanvas? Defining the ecosystem.
If you go right to the top of their verified GitHub organization page, you're going to see this exact definition. PlayCanvas is a web graphics creation platform. And I really want to emphasize that word, platform. It's not just a single script. It's not a basic utility library. It is an entire interconnected suite of tools designed to facilitate literally every single step of bringing immersive graphics to the web.
Section 2. Why it matters. Community and tech. Now, what's really interesting about this is the sheer scale. 16,154. That is the number of stars their core engine repository has racked up on GitHub. And in the open source world, stars are pretty much the ultimate currency of community trust and developer enthusiasm, right? A number this high proves that PlayCanvas isn't just some weekend experimental project. It is a vital, heavily relied upon piece of infrastructure for modern web development. And a huge reason they've built that level of trust is that they rely entirely on open web standards. PlayCanvas is built to leverage WebGL for standard graphics, WebGPU for your next-generation high-performance rendering, WebXR for natively running virtual and augmented reality right in the browser, and GLTF for super efficient 3D model formatting. They aren't trying to lock you into a proprietary ecosystem. They're utilizing the absolute bleeding edge of open web technology so their platform runs everywhere, from a massive gaming PC all the way down to the smartphone in your pocket.
Section 3. The engine. The core runtime.
So the PlayCanvas engine repository is really the foundational heartbeat of the whole ecosystem. It's a wildly powerful, completely open source web graphics runtime written primarily in JavaScript. And the fact that it has over 1.9K forks, that means developers aren't just downloading it. They're actively modifying it, experimenting with it, and contributing back to the core code. This runtime is the invisible heavy lifter executing all the logic, the physics, and the rendering when you load a PlayCanvas experience. Section 4. The editor. Visual build-in. So the crucial point here is understanding the difference between the two main pillars of their platform. On one hand, you have the engine, the code-heavy runtime powering everything in JavaScript. But on the other side, you have the editor. This represents their browser-based visual builder. So while the engine handles the complex math, the editor gives 3D artists, designers, and developers a really user-friendly visual interface, written mostly in TypeScript, so they can construct these WebGL, WebGPU, and WebXR applications without having to manually code every single spatial coordinate by hand. And the editor definitely doesn't exist in a vacuum. PlayCanvas gives you this incredibly rich suite of supporting tools to boost the whole developer workflow. They've got PCUI, which is a dedicated UI component library specifically for building web-based tools. There's Create PlayCanvas to quickly scaffold a brand new project. They even maintain a VS Code extension to beautifully bridge the gap between your local coding environment and their visual editor. Oh, and a web components library for building declarative apps. They've seriously thought about every single step of the developer journey. Section 5. Gaussian splat tools. Cutting-edge 3D. Let's move to and see how this builds a complete processing pipeline. Now, if you haven't heard of 3D Gaussian splats, it's this revolutionary technique using machine learning to turn standard 2D photos into highly realistic, completely navigable 3D scenes. PlayCanvas has structured this beautifully across 3 open-source repositories. Step 1 is Splat Transform, a command line tool for processing and converting your splat data. Step 2 is Supersplat, their dedicated editor to actually refine and manipulate the splats. And step 3 is Supersplat Viewer, a really high-performance tool to display the final results. It's literally a complete start-to-finish workflow. And the community demand for this specific tech? It's staggering. The Supersplat editor alone has absolutely exploded, with over 9,400 stars on GitHub, plus over 1,000 forks. That makes it one of their most popular repositories across the board, right behind the core engine. It just goes to show that PlayCanvas isn't sitting around maintaining legacy tech. They are actively leading the charge in open sourcing the next generation of 3D rendering.
Section 6. Developer Ecosystem, the Big Picture.
And this brilliantly illustrates the technical DNA of PlayCanvas as a whole. Looking across their top repositories, you'll see a perfectly balanced split between JavaScript and TypeScript, each making up about 35% of their core codebases. But they also heavily leverage lower-level languages where raw performance matters the most. You've got C++, Python, and C, each making up about 10%. It's a highly sophisticated, polyglot ecosystem tailored exactly for the demands of high-performance web graphics. To summarize the sheer scale we're dealing with here, we are looking at an organization actively maintaining 74 total repositories, backed by a following of over 4,100 developers. They're based out of London, UK, but their impact is entirely global. And really, most importantly, their core tools, from the engine to the editor to the cutting-edge Supersplat pipeline, are all governed by open-source MIT licenses. They're basically empowering developers by keeping the foundational building blocks of the 3D web totally open and accessible to everyone. So we've explored the underlying engine, the visual editor, and that groundbreaking Gaussian splats pipeline. PlayCanvas has laid down an incredible, completely open-source infrastructure for the future of interactive graphics. The tools are all right there, waiting on GitHub. So my question to you is, with all of this unbelievable power now natively living right in the browser, what are you going to build? Thank you so much for joining me on this explainer, and definitely keep exploring.